Okay, we're going to review graphing log functions using transformations. So what I want to look at here is what the parent function is. So the parent function is log base 2 of x equals y. There's a couple things that I'm doing. It's actually 3 things I'm doing. This negative means a reflection. The argument has an addition subtraction included. Therefore, we're going to have a horizontal movement. And then plus 4 is on the outside of the function, so we're going to have a vertical move as well. Let's first talk quickly about this negative on the inside of the function. I've got y equals log base 2 of negative x plus 1. So if I look at this, I wanted to see what I was taking the opposite of in the argument. So I look at the argument and I say, what was the opposite of the argument? Well, the argument must have been x plus 1 because its opposite would be negative x minus 1. That right there is my reflect over y. So this is a reflect over the y-axis. The plus 1 is a shift left 1. And then plus 4 is up 4. Now we do this if we are going to reflect over the y-axis first. And I always reflect first. So that's why I have to find out what the opposite of my argument is. So what was the original argument before I took the opposite of it? So this tells me that I'm going to reflect over y. Therefore, instead of having a graph that's going to come up and go to the right, I'm going to have a graph that's going to come up and go to the left. Then, so all these points will be reflected over the y-axis, like that. Then I'm going to take them and I'm going to shift them left 1 and up 4. Now when I went left 1, the asymptote, let's grab that asymptote, the asymptote went left 1 as well. And this is what my graph would look like. Now let's say, I'm going to draw a graph for you here, and this is what I would like you to ponder, is how would I write the equation for this graph right here? Let's say it has an asymptote of x equals 2. And let's say my points are here. Here. There. And there. I think that's about right. Whoa. Okay, something like that. What would our equation be? Well, we know this is a log base 2 of x. And I know I'm reflecting it over the y-axis. So I know I have an opposite of some argument in here. I also know that I shifted down a certain number of of points. So I'm going to go back to when I shifted or when I reflected over the y-axis, my 1, 0 ended up over here, but then I'm shifting it 1, 2 to the right and 2 down. So 2 to the right normally looks like x minus 2. And then 2 down is a subtract 2 on the outside. So what you might see people write in a textbook is something like that. And you could always test your answers by putting some values in and see if this equation really does work. So if I put positive values of x, let's just say if I put x equals 3 or higher. If I put a 3 in, I'm going to end up with a negative argument, which I'm not allowed to have. So that means that so far this equation is making sense. If I put a 0 in for x, if I put a 0 in for x, I'd have log base 2 of 2 minus 2, which is equal to y. Well, log base 2 of 2 is 1. 1 minus 2 is negative 1. Y equals negative 1 when I put a 0 in for x. So if I put a 0 in for x, I would end up with negative 1 on the y-axis. So you can see that this equation makes some sense. So just a quick review for reflections, and I chose the hardest one so that you could reflect over y. Make sure you go back and check and review reflecting over the x-axis, and we already did our vertical and horizontal shifts. So as long as you go back and review reflecting over x and know the difference between reflect over x, reflect over y, and most importantly, when you reflect over the y-axis, we need to pull the negative out of the argument so we can see which shift our left and right is going.